Hi guys, my name is Sharvin Kaleselvan. This video is about problem-based tasks for subject network design. So let's start from part 1, which is examine the network requirement. Part 2 is about design a hierarchical IP addressing scheme. Part 3 is about assign and configure IP address on the network devices. Part 4 is about verifying connectivity on directly connected network. Part 5 is about configure EIGRP routing protocol on each router. Part 6 is for verify EIGRP routing. Okay, let's start from part 1. Okay, examine the network requirement. Okay, answer all the questions below with an elaborate explanation. How many subnets are needed? Okay, the subnet are needed for the network is 6. So you can see here. Sorry, you can see here. Uh, this router required three subnet for which is one for connected between R1 to uh, R R1 to R2 and R1 to R3, R1 to R4, and another three will be connected between R2 to the R2 to its LAN, R3 to its LAN, and R4 to its LAN. So it required six subnet yeah, six subnet to this network. So six subnet is needed for this network. Okay, so the second question will be the what is the maximum number of IP address that are needed for single subnet. Okay, the single subnet. Okay, you can see above here. The R2 LAN will require 120 host IP address. So the nearby host is 128. So the maximum needed is 128 IP address for a single subnet. Okay, third question will be how many IP address are needed for each lens. Okay, each LAN have 5 devices, so it will needed 5 IP address for each devices, and plus the interfaces connected to each LAN, which is a fast ethernet 0/0 in a router. So including 5 devices with IP address plus the interface fast ethernet 0/0 in router, including that each LAN will be needed 6 IP addresses. So that's the answer for uh, question number 3. The question number 4, how many IP addresses are needed for all the connection between routers? So we have 3 connection. Router 1 got 3 connections, which is to R2, to R3 and R4. Each of the serial interfaces in the R2, R3, R4 got each IP address which is connected to R1, and R1 interfaces which connected to the 3 routers to R2 and R3 also have 3 IP addresses, which is combined together will be 6 IP address needed for all the connection between the 4 routers. So that's the answer, which is 6 IP address needed for all the connection between routers. Okay, question number 5 will be what is the total number of IP address that needed? Okay, each LAN will be needed 6 IP address. So here got 3 LANs. 3 times 6 will be 18. 18 plus uh, the IP address needed for all routers will be 6. 6 plus 18 will be 24. So the IP address needed for total number of IP address needed is 24. So that's all in part 2. Okay, let's go to that's all in part 1, which is examine the network requirement. Okay, let's go to part 2, which is design a hierarchical IP scheme. Okay, subnet 192.168.8.0 /22 as per requirement. Calculate and assign the subnet to the network. Show your calculation for each subnet. The subnet will be assigned to the network to allow the route summarization on each of the routers. Assign subnet 0 to R1 to R21, which is this this area of connection. Assign the subnet 1 to R2 line, which is this area, cover this area. Assign subnet 2 to R2, R1 to R31, which is cover the subnet will cover this area. Assign subnet 3 to R3 line, which is cover this area, R3 line. Assign subnet 4 to R1 to R41, which is connected to this. The subnet will assign to this area. Assign subnet 5 to R4 line, which is the subnet 5 will be cover this area. Okay, fill the table below for subnet assignment. Okay, I use each of the subnet I use 128 euros. So let's start from the 192.168.0 address. If we take 128 subnet, the first will be 128 will be the next network for the second subnet number 1, and the 128 minus 1 will be the broadcast address. Other than that, all the IP address are usable IP address, which is except the network address and the broadcast address. So plus 1 will be from network address, plus 1 will be first usable IP address. From the network address subnet 1, sorry, uh, the network address from subnet number 1 will minus 1 will be the broadcast address for the subnet 0, and minus 2 of the sub subnet number 1 network will be last usable IP address. So same goal for go for all subnets, which is for subnet 1, 2, 3, 4, 5 and 5. Okay, we here got 6 subnet. Okay, we are done our part 2, which is design a hierarchical IP addressing scheme. Okay, now let's go for part 3, which is assign and configure IP addresses on the network devices. So assign and configure IP address on router 1, router 2, router 3, router 4. Assign and configure IP address on the host devices, PC and printers of R2, R3 and R4. So I uh, fill the table below with the IP addresses. So here you can see the devices and the interfaces which is connected to each router. R1 got 3 interfaces, R2 got 2 interfaces, R3 got 2 interfaces, R4 got 2 interfaces. So the addresses for each router interfaces can see the IP for each LAN devices, which is R2 LAN devices IP addresses and its subnet mask, R3 LAN devices and its IP addresses and subnet mask, R4 and its LAN devices IP addresses and the default gateway and subnet mask. Okay, that's all for part 3. Assign and configure IP address on the network devices. Okay, part 4 will be verify connectivity on each. Sorry, before part 4, we have to assign the IP address on each network devices in the packet tracer. So let's start from R1, CLI, enable config terminal, no IP domain lookup, interface serial 0/0/0. IP address will be 192.168.8.1. The subnet will be 255.255.255.128. Now shut, exit, exit. Let's go for serial 0/0/1. IP address will be 192.168.9.1. The subnet also same 255.255.255.128. No shut command. Okay, exit from the interface. Go to serial 0/0/0/1/0. The IP address will be 192.168.10.1. The subnet also same 255.255.255.128. No shut command will be given. Okay, and from that and copy and start to save the configuration we have done so far. Okay, and let's go to the R2 and configure its assign IP address to each interfaces given in addressing table below. Config terminal, no IP domain lookup and interface serial 0/0/0. IP address will be 192.168.8.2 255.255.255.128. I should command to off the interface and exit from the interface. Go to fast ethernet 0/0. IP address will be 192.168.8.2.129. Okay, the subnet will be 255.255.255.128. No shut command to off the interface. Okay, and from that copy and start to save the configuration. Okay, we assign for IP address for LAN devices. Okay, let's start from host A. IP address will be 192.168.8.130. Subnet will be 128. Default gateway will be 192.168.8.129. Okay, let's go to the host B in R2. 192.168.8.131.131. Okay, subnet also same 192.255.255.255.128. Subnet mask will be 192.168.8.129 will be which will be the fast IP address of R2 in fast ethernet 0/0. Okay, IP for let's configure printer A. The default gateway will be 192.168.8.129. The IP address will be 192.168.8.132. The subnet mask will be 255.255.255.128. Okay, let's go to the R2 in OC. We do same 192.168.8.133. Subnet mask will be same 255.255.255.128. Thus, default gateway will be 192.168.8.129. Okay, R2 hosting. Okay, let's configure for last last device in LAN R2. The IP address for OSD will be 192.168.8.134. Subnet mask will be 255.255.255.128. The default gateway will be 192.168.8.129. Okay, let's done in R2 LAN. Let's go for R3. Config assign IP address to R3. Enable config terminal INT serial. Sorry, no IP domain lookup INT 0/0/0 serial 0/0/0. IP address will be 192.168.9.2.255.255.255.128. Shut exit from the interface. Go to fastnet 0/0. IP address will be 192.168.9.129. Default gateway will be 255.255.255.128. Now shut command and from the config terminal and copy runs the close into the configuration. Okay, let's assign IP address for the devices in R3 LAN. Let's begin from host A. The IP address will be 192.168.9.130. The default gateway subnet mask will be 192.255.255.255.128. The default gateway will be 192.168.9.129, which is IP address of fastnet 0/0 in router 3. Let's go for host P R3 192.168.9.13131. The subnet mask will be 255.255.255.128. The default gets also same 192.168.9.129. Let's go for printer B. Default gateway will be 192.168.9.129. The IP address will be 192.168.9.132. Subnet mask will be 255.255.255.128. Okay, let's go configure assign IP address in OC R3. The IP address will be 192.168.9.133. The subnet mask will be 255.255.255.128. The subnet mask will be 192.168.9.129. Okay, let's assign IP address for host D 192.168.9.134. The subnet mask will be 255.255.255.128. The default gateway will be 192.168.9.129. Okay, let's configure the IP address in R4. enable config terminal, no IP domain lookup, go to serial 0/0/0 interface, IP address will be 192.168.10.2. The subnet mask will be 255.255.255.128. Now shut command to up the interface. Exit from the interface, go to interface fastnet 0/0. The IP address will be 192.168. The IP address will be 192.168.10.129. The subnet mask will be 255.255.255.128. Now shut command to up the interface and copy run start to save the configuration we've done so far. Okay, now let's configure assign IP address for 5 devices in R4 LAN. The IP address will be 192.168.10.130. Subnet mask is same as usual, 255.255.255.128. The default gateway will be 192.168.10.129. Okay, let's configure OSP. The subnet mask IP address will be 192.168.10.131. Subnet mask will be 255.255.255.128. The default gateway will be 192.168.10.128. Sorry, 129. Okay, let's configure printer C. And default gateway will be 192.168.10.129. The IP address will be 192.168.10.132. The subnet mask will be 255.255.128. Okay, now let's assign IP address for OC in R4 LAN, which is IP address will be 192.168.10.133. The subnet mask will be 255.255.128. The default gateway will be 192.168.10.129. Okay, the host in LAN 4 IP address will be 192.168.10.134. The subnet mask will be 255.255.128. The default gateway will be 192.168.10.10.129. Okay, now we are done. Part 4, which is assign and configure IP address on the network devices. We already assigned the IP address in 4 routers and the 5 all the devices in the LAN, R2 LAN, R3 LAN and R4 LAN. Okay, now let's go to part 4, which is verify connectivity on directed connected network. So let's take R2 and ping to the connected network connected IP address, which is 192.168.8.31 will be host B, R2 host B. Okay, you can see the connectivity is successful. Okay, let's take 192.168.8.132 will be R2 printer A. Okay, the connection also successful. Okay, let's take R2 host C. The IP address will be 192.168.8.33.133. Okay, the connectivity is successful. Okay, let's take R2 host D IP address, which is 192.168.8.134. Okay, the connectivity also successful, which means the R host A successfully pinged to host B, printer A, printer C, and printer A, host C, and host D in R2 LAN. Okay, let's ping default gateway, which is the IP address of interface fast Ethernet R, fast Ethernet 0/0 in R2 192.168.8.129. Okay, the connectivity is also successful. Okay, which means all the uh, IP address in the LAN network successfully ping each other. Okay, let's go through the same method to all the network, which is R3 in R3 lane and R4 lane, which let's begin in R3 lane. Okay, let's ping to R3 host B, which is IP address will be 192.168.9.131. Okay, the IP address is successful. Let's ping R3 host B, host printer B. Okay, the ping to print R3 printer B is successful. Let's ping R3 host C. Okay, the ping from R3 host A to R3 host C also successful. Let's ping R3 host D. Okay, you can see R3 host A to R3 host D also successful. Okay, let's ping to default gateway, which is IP address in fast Ethernet 0/0 in R3 129. Okay, the ping to default gateway is also successful, which means uh, the LANs R3 LAN are connected between each other. Okay, let's do the same method in R4 LAN. Ping to R4 host B 192.168.10.131. The connection is successful. Let's ping to R4 printer C. The connection is also successful. Let's ping to R4 host C. The connection is successful. R4 host D. The connection is also successful. Okay, let's ping to default gateway, which is IP address of fastnet 0/0 in R4. Ping 192.168.10.129. Okay, the connectivity to default gateway is also successful. Okay, which means uh, each LAN, the R2 LAN and R3 LAN and R4 LAN are connected between uh, each other. So we are done our part 4, which is verify connectivity on direct network. Okay, let's begin our part 5, which is configure EIGRP routing on each router. Okay, let's begin from R1. Enable config terminal router. Okay, before configuring EIGRP, let's see the first. Just configure EIGRP using on autonomous system number 10. Configure EIGRP to route all the directed connected network for R1, R2, R3 and R4. Okay, we have to give router EIGRP 10 because they give autonomous system number 10. Okay, and do show IP route C. Okay, these are the directly connected network. So I have to give network 192.168.8.0. Also, we can also give the wildcard bit or not wildcard bit. So I give stately. Okay, the second network will be 192.168.9.0. The third network will be 192.168.10.0. Okay, after that we have to give command N and copy run start to save the run configuration we have done so far. Okay, let's configure EIGRP in R2. Config terminal, router EIGRP 10 because they give autonomous system number 10. Okay, do show IP route C. Okay, the connected network are these, so I have to give the IP address. It's a network 19 network 192.168.10.8.0. Okay, and copy run start to save the run configuration we have done so far. Enable config terminal, router EIGRP 10 because they give autonomous system number 10. Network, sorry, before give the network, do show IP error C. Okay, you have to give network for the directly connected, which is 192.168.9.0. The second network will be 192.168.128 and copy run start to save the configuration we have done so far. Okay, let's give EIGRP in R4, enable config terminal, router EIGRP 10 because they given autonomous system number 10. Do show IP route C to see the directly connected IP route. Okay, let's give the network now 192.168.10.0 and second network will be 192.168.10.128 and copy run start to save the configuration. Okay, we are done our part 5, which is configure EIGRP routing protocol and each router. Okay, now let's start our part 6, which is verify EIGRP routing. So before I verifying EIGRP routing, I have to ping between R2 to R3. Make sure the R2 to R3 host A and R4 host A. Make sure the EIGRP is working correct or not. Okay, let's see the R3 host A IP address. Ping IP config to see the IP address. Okay, this is the IP address of R3 host A. IP config. Okay, this is R4 host A IP address. Okay, let's ping to R3 host A IP address, which is 192.168.9.130. Okay, it's successfully pinged to R3 host A. Okay, let's ping to R4 host A. Okay, ping from R2 to R2 host A from R2 host A to R4 host A also successful. Let's trace it to R3 host A. where the destination the packet is travel to where travel. Okay, you can see the packet is travel from the R2 host A to the fastnet 0/0 R2 to to serial. uh, okay, this IP is R2 host A IP address, and this address is fastnet 0/0 R2 address, and this address is fastnet 0/0/0 in R3, and this address is R3 host A IP address. Okay, okay, now let's verify EIGRP routing on R1. Go to enable CLI, enable show IP EIGRP neighbor. Can see the neighbor in IP EIGRP R1, which is IP of R2, R2 serial 0/0. This is IP for R, sorry, this is IP for R3 serial interface 0/0. This is IP for R2 serial 0/0/0, and this is the IP address for um, interface serial interface 0/0 in R4. Okay, now let's verify the EIGRP routing in R2. Okay, they ask check the routing table of R3, R4, R2, R3, and R4. Let's check the IP EIGRP first. Okay, this address is connected to fastnet 0/0. Sorry, the serial interface 0/0/0 in R2. Sorry, this is the IP address of uh, serial 0/0/0 in R1. And let's check the before the answering this question, let's verify the EIGRP routing in R3 and R4. Same also show IP EIGRP neighbor. Okay, same also. This is the IP address of uh, serial 0/0/1 in route 1. Enable config terminal or it show IP EIGRP neighbor. Okay, this is the same also. This is the IP address of serial 0/1/0 in R1. Okay, now let's see. Check the routing table of R2, R3, and R4. Okay, let's begin from R2. Show IP route. Okay, by giving show IP route, uh, how many routes are in each route? How many routes are in each route routing table? The first is check the IP routing table of R2 and R3 and R2, R3, and R4. These are the routing table. C is meaning for connected. D is meaning for EIGRP. You can see above. Okay, these are the directly connected. which is for address network address of serial 0/0/0 in R2. This is the serial network connected to fastnet 0/0 in R2. Okay, you can see here is the network connected via EIGRP using this IP address, which is for IP address in serial 0/0/0 in R1. Same also it advertising the network of 192.168.9.0 and 192.168.10.0 networks. Yeah, the same interfaces, which is serial 0/0/0 in R1, which is this IP address. Okay, let's see the R3 now. Show IP route. Okay, same also directly connected. We have two directly connected networks and two direct two network connected via ERGRP. The first directly connected network is um, 192.168.9.0 network, and another network is 192.168.9.128, which is fastnet 0/0. Another one is a network of serial interface 0/0/0. Okay, the first ERGRP is 192.168.0.8.0, which is advertising the R2 LAN via the IP of serial interface 0/0/1 in R1 using the interface of serial 0/0/0 in R3. Okay, the another ERGRP network also same, it advertising network of 192.168.10.0, which is the network of R4 LAN. It's connecting via 192.168.9.1, which is the interface of IP address of serial interface 0/0/1 in R1, uh, R1 using the serial interface 0/0/0 of R3. Okay, let's see the R4 routing table. Same also show IP route. Okay, here got same also two network advertise using EIGRP and two network connected directly connected network. Okay, let's see the directly connected network first. The first network is directly connected by serial uh, interface serial 0/0/0 of R4, and another network is connected using fastnet 0/0, which is the first network will be 192.168.10.0 using serial interface 0/0 in R4. The second network is 192.168.10.128 network using fastnet 0/0. Okay, let's see the ERGRP network. Okay, the first network will be 192.168.8.0, which is the R2 LAN network. It connected via 192.168.10.1, which is the IP address of serial interface 0/1/0, which is for R1, and using the interface of uh, serial 0/0/0 in R4. It goes for same to LAN R3, which is network will be 192.168.9.0 via the same IP address of serial interface 0/1/0 for R1. connected via using serial interface 0/0/0 in R4. Okay, let's check the routing table of R2 and R2, R3 and R4. Check how many routes in each routing table. We got two routes in R2, two routes of EIGRP in R2, and two routes of EIGRP in R2. Goes for same in R3 also. Got two routes of EIGRP in R3, and same for R3 also. R4 also got two routes of two routes of EIGRP in R4. Okay, each R2 and R3 and R4 got each four EIGRP routes. Okay, any of the routes summarized? If so, which one are summarized? Okay, in R2, R3, R4, let's see any of the routes are summarized or not. You can see didn't have any route summarized in R2. Okay, in R3 also same, we didn't see any summarized routes. In R4 also same, we didn't see any summarized route, which means there are any of the route summarized is there is no summarized routes. Okay, let's see we got summarized route in R1 or not. This is like an additional. Let's see. Okay, they got summarized route. You can see here 192.168.8.0 is summary. They also got same. 192.168.9.0 is a summary, and here also same 192.168.10.0 is a summary. Okay, here got three. R1 got three summarized route, but in the routing table of R2, R3 and R4 they didn't we didn't have any summarized routes, so the answer will be no for the question number 3. So that's all in problem based task for subject network design. Thank you very much.